So now we are ready to go, and we're recording the screen here, and I hope everyone's doing all right. Welcome to week 12. Can you believe it? After this week, we have one more week of class, and yeah, that's where we're at. We're doing very well. So, is there a test going out there today? There could be. Yeah, or is that next week? I'm not quite sure, but there's still one more to go before the final test. So I can't remember if that's there. That's going to open up there today. I've got the test ready to go, but I'll let you guys know. And so the quiz for the cardiovascular, that was great. Class average is outstanding. You guys just keep doing whatever it is you're doing. Okay, don't change a thing. And you're looking at a decent finish, and that's what we're looking for there. Today's class there is on urinary, okay, and we'll get that going there right now. There's two parts, so what we'll probably do is, I don't know if I'll go right through or and do the two PowerPoints, or I'll stop. I'll probably stop for 5 minutes and stop the recording. And but that's what's going to go on there for today. Don't forget about your assignment 2 on the nervous system. I think those are due for upload. I've still got there's a whole bunch of them there that have already been uploaded. So let me know if there's any issues with that. But honestly, we're just looking there for a smooth finish. Okay, and just keep going. And if there's any issues, and some of you guys have contacted me there, let me know if there's any issues going on, because we have 2 weeks. If there's any issues, and 2 weeks we can fix anything. Okay, but let me know if there's any issues. Okay, and other than that, I think we're doing all right. Is there anything there that I can do? Are there any questions there that you guys have? Yeah, cheers. And if you guys don't have anything, then we'll just go on. But keep me posted. You guys have my email. All right. And let us go, shall we? There we go. Come on, internet. Don't let me down. Oh, dear. What is wrong with the internet? No. There we go. So I think that we can see here, and you guys are sharing. It should tell me there that I'm sharing. Okay, there we go. Oh, great. And there, the cat won't stop. Come on, minimize. Why won't that just let me move? Okay, there we go. Good enough. So there we go. There is this is chapter 24. Sorry, just a little bit behind here. No, I think we're all right. Just been a crazy morning again. Now, you guys can hear me, and your microphones there. You guys are muted, but let me know if you guys can't see something, or if the screen isn't sharing. All right, but here we go. Welcome to the kidney. This one here, we usually do this one there at the end, because the kidneys there, you need the totality of all the other organ systems there in order to be able to do the urinary system. So this one here is the pièce de la résistance. This one here is the best one. All right. There's a couple movies there. You guys can hit these up. I won't play them here, but they're really good. Okay, so make sure to hit these movies there, and hopefully there are those links. I don't see those links as showing up, but they should be. That is awfully strange. Slideshow from beginning. What is wrong with the computer? So slow. Yeah, there we go. They do work there. Okay. So make sure to hit those movies. All right. Not right now, but after the PowerPoint there. But let's go, shall we? Urinary system here, we're talking about solution chemistry. And when I mean solution chemistry, if you take sugar and, a spoonful of sugar and, throw it into a glass of water and you stir it around and all of a sudden the sugar is gone. Now you have, this sugary solution. You have a solution. You have a solid, solute dissolved there into a solution, right? A solvent. And that's what kidneys deal with. They deal with solution chemistry. Things dissolved in the blood. All right? So let's have a list here. Number one, we'll talk about the organ systems involved. Okay? Describe the major organ systems there, organs of the urinary system. Then we'll look at the structure, blood supply, nerve supply, function of the kidney. Is there anything there that they don't do? Watch and see. They're pretty bananas. The cell of the kidney is called the nephron. Okay, and we'll look at that. 3 processes involved in the formation of urine. Okay, there is filtration, reabsorption, secretion. Describe the hormonal control of water and electrolytes there for kidneys. We'll talk a little bit about this. We'll continue on there in the next PowerPoint. Okay, this is chapter 24. That stuff there is kind of chapter 25, but we'll talk about it there as well in this one. We'll look at urine itself. The whole idea there that would you believe it? Like we only have 5 liters of blood, but the kidneys there, they produce 180 liters of filtrate a day. They filter 180 liters, okay, and they produce 180 liters. But really, we urinate there for maybe about a liter and a half, 2 liters a day. And it's quite amazing what goes on here. So it's a really, really, really good week to learn. This is a good one here. We'll look at the ureter, urinary bladder, urethra. We'll get into all these kinds of stuff. Lots of good stuff there today. Organs of excretion. You've got the kidneys. Okay, here we're talking about solution chemistry, as I said. How do you remove, and you think about that, if you have that sugar in water, how do you separate that sugar from that water mechanically? It's not an easy thing, but the kidneys do quite well, and we'll look at this right now. Skin, sweat glands, lungs, intestines there. We've covered this stuff, okay? The whole idea there that if you drink alcohol there, the next morning there, you can smell it in the person's breath. Intestines there, small intestines, okay, for absorption of food, but large intestines there for excretion of feces. Skin, sweat glands. Yeah, you guys know your skin is very porous. Just a nice little shot here of the organs of the urinary system. You'll see your 2 kidneys here. Okay, you'll see that the left one sits higher than the right one. Okay, great word is retroperitoneal. We'll look at that there in a little bit. That's their official positioning. Then you'll see the ureters come on down. Okay, that connect there to the bladder. And then you have the urethra for excretion to the external world. But you'll see there that there's your descending aorta. And here's your vena cava. And you'll see there that the kidneys are right off of these. And so with the kidneys there, it's all about pressure. And if the kidneys aren't getting the blood pressure there that they need to do their jobs, then they make a phone call upstairs. But you'll see how in close proximity these kidneys are to these massive, massive blood vessels. Okay? So there is not much to the kidney, all right? There's one of the movies there where they inject wax, different colored waxes into, the kidney there, and you can see there just the different sections of it. But you'll basically, to start off with, okay, you have we saw the big blood vessel there, the descending aorta coming on down the abdominal aorta. And then you have the renal artery, and this is how the blood gets filtered. And that's what the kidneys do. They filter the blood, right? The blood comes in, and this is an artery. So this is huge pressure, right? And then the blood goes all the way. This is what we call the cortex, all right? The renal cortex right here. You can see the cortex right here. So the outside layer here is called the cortex. And then you see these triangles in here. Basically from here on this whole area in here, this is called the renal medulla. Okay? And these are called renal pyramids. So this area is called the medulla. This outer area there is called the cortex. Okay, and you see the fibrous capsule there that encapsulates the cortex right in there. Okay, so you have your renal medulla, your renal cortex. Within the renal medulla, you have these pyramids. Okay, and I'm just going to move through the flow of blood here, and the videos do a great job of it, but I'm not going to play the videos here during this video here. But you'll see the blood comes in, and it's a heck of a pressure. Whack! And it comes right in out to the cortex right here. And we'll show you what the nephron is in a bit. That's the cell, okay, that actually does the filtering there of the kidney. But those nephrons, they kind of hang out at this area up in here between the cortex and the medulla. And the blood, the unfiltered blood comes in here, gets filtered. Okay, and the filtered blood then returns back, okay, and goes out again. The urine itself, the constituents there of the blood, okay, that get filtered, they go through these pyramids here, these reverse pyramids, you know, with the points at the bottom here. And the urine comes down into what we call a calyx. And that's these guys here. They're called minor calyx. Calyces for plural. Okay, and the urine comes down into a major calyx. Minor, 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 major. And then down into the renal pelvis in this area right here. Okay, and that everything kind of happens. You see that a kidney kind of looks like a kidney bean, right? Hence the name. And you'll see this little indentation area here. We call this there the hilum. All right, and that's where everything happens. So the blood comes in, gets filtered. The filtered blood then leaves. Okay, the urine comes down here through these renal pyramids. Okay, and we'll show you there's actually renal papillae, these little holes here at the bottom of the renal pyramid there. But the urine comes down into a minor calyx, major calyx there, the renal pelvis, and then eventually down into the ureter, where it goes down into the bladder. Okay, so there are some things going on in here, but it's not too bad. It's not like the heart, okay, where you've got all these other things going on here. So again, there's your cortex is on the outside. This area here is called your medulla, which has these pyramids in it. And the urine formation, the urine gets made, it trickles down here, down a pyramid, down through a minor calyx to the major calyx to the renal pelvis, out the hilum here, and down the ureter. Okay, we'll look at more of these there in a little bit more detail. Can you believe it? All right, so the nephron unit. Here we're talking blood vessels here. You got the renal artery, remember afferent. Okay, you guys are doing your nervous system. You guys remember there that afferent means at home. It's coming towards the body. Efferent means exit. It's leaving the body. It's kind of it's going in that direction. Okay, we'll look at a word there called glomerulus. We'll look at peritubular capillaries. We'll look at the renal vein. We'll look at all these there. This is when we get into the microscopic. So just a different shot here. There's your abdominal aorta, okay, carrying oxygenated blood. Here's your inferior vena cava, carrying carbon dioxide blood back to the heart. Okay, here are the kidneys themselves. You'll notice again your left one sits higher. Okay, and that little indentation there, that's called your hilum. Okay, adrenal glands there. This is endocrine. We'll hit these there next week for sure. Okay, The adrenal glands there, very important. Okay, epinephrine, adrenaline. Okay, production in times of need. All right. But on the outside there, the kidney there, there's your renal capsule. Okay, and we've cut a kidney open here. There's your cortex on the outside, your medulla there on the inside. There are your pyramids there. And you'll see there minor calyx, these guys in here, to a major calyx, bigger area, and then out the renal pelvis, and then out the ureter. Okay? Good blood vessels going in there. And just notice there that coming off the aorta, there is your renal artery. Artery there, okay, carrying oxygenated blood. Okay, and then you have the renal vein. Okay, we'll get there. There's your renal vein, better shot there. Okay. So, kidney function. Regulate blood volume and electrolytes. There's your solution. Now remember there, the kidneys, they do regulate blood volume. Okay, that whole idea there that if you are thirsty, that all came from the kidney. And you think there that we have 5 liters of blood. That's all we have. So you think of our cardiovascular system as a 5-liter jug. That's it. Okay? And, you know, you could top that up to 5 liters so that the whole thing is full. Or, you know what I mean, you could be a little dehydrated and, you know, you don't have enough water in your system, so you only have 4.5 liters of blood, right? And you think about the pressure there. In what situation, a full 5 liters or 4.5 liters, would you have the most pressure on the system? And you think about that. If your system is topped up with blood, if your maximum you can hold is 5 liters and that's all you have is 5 liters and you're full, okay, that's going to produce the most pressure. And that's what the kidneys need. If they don't get the blood pressure that they need, because it's that pressure, okay, every heartbeat there, the heart provides pressure. And the kidneys require that pressure in order to filter the blood, okay? And if they don't get the pressure, they make a phone call upstairs. And how does the kidney increase blood pressure? By making you thirsty, okay? It's going to stop, you won't have to urinate, okay? The whole idea there that it will keep water in from one end and it will make you thirsty, so you'll dump in water from the other end. Okay, and that's how you increase the blood volume. And if you increase the blood volume, you've now increased the blood pressure. Regulate acid-base balance, nitrogenous waste. There's your urea. Regulate blood pressure. And also, the bones make the blood, but who tells the bones what to do? It's the kidneys. Okay. So if you think about it there, the heart, the cardiovascular system, it's more of the donkey. It's the the hard worker. But the brains behind the operation, they are the kidneys. So take care of your kidneys. Filtration of metabolic waste there from the blood, absolutely. Collection and excretion to the outside body, and regulation of RBC production, blood pressure, calcium ion absorption, volume composition, and pH of blood. Like, holy smokers, kidneys do a lot. They are awesome. Let's go. So here is a shot there of the nephron. Okay, so this, and it's a very strange looking cell. Okay, but highly specialized, localized there in the kidney, and this is the process of how urine formation goes. The glomerular capsule receives blood there from the afferent arterial. Afferent means it's coming towards you, okay? Carrying oxygenated blood towards the kidney and passes it to the efferent arterial. Okay, now it's on its way out. The efferent arterial gives rise to what we call the paratubular system, which surrounds the tubule. So you'll see there that there's your afferent. This isn't the greatest of slide. I have a better one there that I'll show you, but There's your afferent arterioles carrying blood to the kidney. And then you'll see there that, actually it's not a good, I'll show you this one right here. There you go. So, think about it. There's your aorta, blood comes in and whack. Okay, that's a heck of an artery coming right in, and there's no hiding this. It's whack every single time, right? So you just think there, the blood is coming in. There's your afferent arteriole. So the blood comes in. There's your afferent arteriole. And then what happens is it hits this ball. And we call this there the glomerulus, or this would be your Bowman's capsule around the outside of it right here. And the blood comes in and huge pressure. And it's the only place in the body where an arteriole meets capillaries. Okay? It's not natural because there's too much pressure here, and these are capillaries. There's no pressure, right? These are microscopic here, and whack. And what happens there? The blood gets whacked, and the constituents of the blood, the solids that were dissolved in the blood, they accumulate in the Bowman's capsule. Okay, I'll just zoom in right here. The blood comes in, hits these capillaries, and the blood is fine. It's too big to get filtered. The blood just continues on here, and now it's clean blood. But all of those constituents of the blood that were in the kidney, they get filtered out. And they now reside in the Bowman's capsule, and they move all those dissolved solids that were just filtered out, they come out. Okay? And there's a whole nother system going on here. Now you see the kidneys, they produce 180 liters of this filtrate a day. You heard me right. The blood we have 5 liters of blood, and it gets filtered. And you'll see there that the stuff that was in the blood, not all of it, but the smaller stuff there, comes out. And the blood is now clean. But you'll see there that this clean blood, wait a second, it circumvents all of this system right here on its way out of the kidney. Yes, it does. Because as we said, 180 liters of this filtrate is produced every day. But we only urinate about a liter and a half every day. So the 180 liters of this filtrate is produced, but you'll see there that it is reabsorbed. And you'll see what's going on here is that filtrate, okay, and we'll talk about, there's 3 different sections that go on here. And these are what we call the peritubular capillaries there that circumvent. But you'll see there that this tubule comes around. So all this filtrate comes around here, and then you remember the cortex? There's your cortex. That's the outside. And you remember those, renal medulla, those pyramids? That's this area right in here. And you'll notice there that part of the nephron resides in the cortex, and the lower half resides in the medulla. Okay, so let's go ahead and try this again here. You've got the blood comes in, high pressure, hits these capillaries here in the glomerulus. Okay, and the blood gets filtered. The clean blood moves on and continues on. Its job is not done yet. All of that filtrate, okay, it collects in the Bowman's capsule and continues on into what we call the proximal convoluted tubule. Don't have to remember any of this, okay? And this section here, these tubules here, some things are reabsorbed back into the blood because we've got 180 liters of this stuff being produced every day. Well, 178.5 liters of it are going to be reabsorbed, okay? That's the deal. And all of this, basically 99% of the filtrate that is filtered gets reabsorbed back into the blood. All right, and that filtrate travels along here. Some of it gets reabsorbed back into the blood, some of it doesn't. It continues along. We'll talk about the different sections here, but you'll see there's your proximal convoluted tubule, and then you have this dip down into the medulla. We call that there the loop of Henle. Okay, this is saltier down here than it is up here, and it draws different things out of the filtrate. We'll talk more about that there in a little bit. And then that filtrate comes up, and there now we're into what we call the distal convoluted tubule. So there's your three sections of the nephron. The first tube there, proximal convoluted tubule. The next section there is the loop of Henle. The third section is your distal convoluted tubule here. And by this point in time, the urine formation is pretty solid. Okay, we've made 180 liters of this filtrate a day, but we've reabsorbed 176.5 liters. So by this point in time, the urine is fairly concentrated, and it goes down, okay, and what we call the collecting ducts here. And it goes down, down, down. And where does it go to? Better shot here. Yeah. And you'll see there that there's your cortex, there's your medulla. That's where the nephrons reside. And those collecting ducts, they continue down. And eventually the urine formation comes down into a minor calyx, major calyx, and then out. That's the process. Go back, pause the video, watch that again, but we'll hit that a couple times there before we get out of here. This is a very simplified shot of the nephron. Okay, remember there's your afferent arterial, afferent at home coming towards, okay, the glomerulus. Okay, now the glomerulus is this collection of capillaries. Capillaries are the only place in the body where you can move things, exchange things. So huge pressure, whack. Okay, and all of the filtrate that was in the blood there that needed to come out, it now collects in the Bowman's capsule and continues on. Now, the first part of these tubules here, you have the proximal convoluted tubule. Proximal just means closest there to the glomerulus. Okay, and then we have, this is the cortex, and now we have the renal pyramids down here, the medulla, and you'll see there that the loop of Henle, you have the descending loop, very salty down here, okay, and then we have the loop, the ascending loop comes on up, and then you have the distal convoluted tubule, and then you have those collecting ducts there, which then go to a calyx. Good little movie there, okay, very simplified. I like this diagram, okay, just, now remember, you're producing 180 liters of filtrate a day. We only urinate about 1.5 liters to 2 liters. So the majority of that filtrate gets reabsorbed back into the blood. So you see the blood initially gets filtered. The clean blood moves around. Okay, we call these there the paratubular capillaries. They circumvent, okay, the tubule system for the whole point of reabsorption. Okay, we initially filter the blood out, but then the majority of the filtrate gets put back into the blood. All right. The glomerular capillaries are specialized, okay, for filtration. That's these guys here. Okay, and removal of waste there from the blood, and regulates water and electrolyte concentration. That's the whole point, right? It's kind of like a reevaluation of the blood, okay, where they clean it, and then they put back what they want into it, and then everything else there can get excreted. These are the only capillaries in the body that are fed and drained by arterioles, okay? No pressure, good amount of pressure. This allows the blood pressure in the capillary bed to be very high, and it forces fluid and solids out of the blood into the Bowman's capsule. As we said, there's your Bowman's capsule. That's where all the filtrate goes. Okay. Most of the filtrate is reabsorbed, though, back into the renal tubule cells and returns to the blood through the paratubular capillaries. That's these guys here. And most of everything gets reabsorbed. All right. Glomerular filtration. In the glomerular or Bowman's capsule, substances move from the blood to the glomerular capsule. Tubular reabsorption. Now here we're talking about urine formation, right? So the initial, that whack, right? The blood gets filtered. The filtrate is created. Okay, so you have that filtering system. But then, as I've said a couple times there, most of that gets reabsorbed back into the blood there. Okay, substances move from the renal tubules into the blood. Okay, so we're moving back. Okay, from the tube system back into the blood. Things are moving this way. Okay. Glucose, water, urea, protein, creatinine, amino acids, lactic acid, citric acid, uric acid, phosphates, sulfates, calcium, as needed. It's all about fine-tuning the blood. That's the whole point, right? We clean it, and then we'll put back in what we want. And then there's the fine-tuning. Substances move from the blood of the peritubular capillaries back into the renal tubules. So the initial section, filtration, and then in this section here, we're still filtering, removing things, but we like to put things back in. And then finally, there's the fine-tuning there that goes on in the distal convoluted tubule there as far as secretion goes. Any type of drugs or anything there that we want to get out, we can get it out in this section here. Okay? So, urine formation, glomerular filtration, water and dissolved solutes filter across the glomeruli into the Bowman's capsule. Why filtration occurs, it's all about pressure. Okay? That arterial bringing the blood in, it's highly pressurized. Okay? What substances are filtered? Water, sodium, potassium, chloride, glucose, uric acid. These are all very small molecules. Large blood vessels and proteins there, they're too big. They don't get filtered. All right? So big molecules here, they don't get filtered out and they just continue on. Okay? The smaller molecules there, they're the ones that get filtered and create the filtrate. Okay? Just a lovely shot there of the glomerular filtration. And you'll see there that there's your afferent arterial. Just zoom in a little bit. I don't know why I did that. There we go. So there's your afferent arterial. Okay, bringing the blood in, pressure. And then here are the capillaries there of the Bowman's capsule. Okay, and the smaller molecules there, they get filtered out and they travel along here, okay, into the convoluted tubule system. And any of the big molecules there, they don't get filtered out and they continue on into the efferent arterial. Okay, and you'll see how that one works there through fenestration. That's the process there of these guys here getting pushed out, okay, through the capillaries. All right. Perfect. There's an electron micrograph there of the glomerulus. Have some fun with it, or not. I thought that this was a great slide right in here. What are the kidneys filtering anyway? Okay, and you'll see there that, yeah, all these different numbers here, sodium, potassium, calcium, magnesium. You'll see what's going on here. But I thought what was interesting, okay, that the whole idea there that you'll notice that glucose, sugar, should never, ever, ever be in the urine. Glucose can be initially filtered out, but it's always reabsorbed back in. That's one of the telltale signs there that that person might be ill, is if they have sugar in their urine. All right, if that ever happens, you want to go to a doctor ASAP. So that's why I put that in there. Just that 0. I thought it was interesting. No sugar in the urine. Glomerular filtration rate at which water and solutes are filtrated. Blood pressure determines glomerular filtration rate. And I'll say that again. Blood pressure determines how well the glomerulus is filtering. And just probably say it a couple more times, but the whole idea there that the blood comes in through this arterial lots of pressure, whack. Okay, and where's that pressure coming from? It's coming from the heart. Okay, and if the heart isn't kicking out enough pressure, and it's not just the heart as well, you need to maintain your fluids, right? You think there that if you're dehydrated, your blood is kind of syrupy, soupy. You don't have enough blood volume in there. So that means the tank isn't full. So therefore, you're not creating the pressure there that you need. So that's why the body there will decrease the amount of urine there you output and make you thirsty, and therefore make you drink a glass or two of water. So therefore now you've filled up your tank, your 5-liter tank. So therefore now you're getting the blood pressure there that you need so the kidneys can do their job. Where were we here? Yeah. Normal glomerular filtration rate there, as we said, 180 liters. So these kidneys are busting it up 24/7. These things here, they're producing about 125 milliliters of filtrate a minute. Okay, and now I didn't say urine, filtrate. What slide is that? I don't want to lose that. That's 18. You'll see there that the kidneys are producing 180 liters of filtrate, but only 1.5 liters makes it down here. That 176.5 liters gets reabsorbed by these blood vessels, these capillaries there that circumvent the glomerulus. Okay, all that filtrate there, most of it gets reabsorbed and back into the blood immediately. Only about 1.5 liters to 2 liters makes it down to become urine. Great shot here, kind of a continuation there from the last slide. The whole idea there, 180 liters of filtrate is produced a day, but really we only pee about, anywhere in this range right here. Okay, so it's all about reabsorption. The kidneys are cleaning, but most of what got cleaned gets put back into the blood immediately. Urine formation, tubular reabsorption. This is after, remember we just talked about filtration, okay? And we talked about what goes on here, okay? This whole idea of BP, filtration, Bowman's capsule, smaller molecules here get pushed out, and then they travel along the tubular system. Now let's look at the tubular system, the next part, the whole idea of reabsorbing that 176.5 liters of filtrate. Returns the filtrate from the tubules to the blood via the peritubular capillaries. Okay, most reabsorption takes place in the proximal convoluted tubule. That's the first section. So most reabsorption happens in the first section. Okay. The kidney chooses the type and quantity of substance it reabsorbs, and we'll have a look at these right here. So, okay, this one here is going the opposite way, which probably doesn't help your perception here. But again, here's your blood flow afferent. There's your glomerular capillaries. Here's your afferent, and then your efferent. And that blood, the blood is not done yet, and it circumvents the whole nephron. And you'll see what goes on here. Osmosis there reabsorbs water in response to active transport, reabsorbing of sodium and other solutes there, and this happens there in the proximal portion of the renal tubule. Okay, so you'll see there that sodium ions are reabsorbed. The negatively charged ions are attracted there. And so the sodium goes first, and then the negative ions there, you'll see sodium is positive, positively charged is a cation. Then you have the anions here, they will follow. And generally a rule, wherever sodium goes, water goes too. So you see the sodium goes, and then eventually there the water goes back into the blood as well. Sodium water filtration, reabsorption, and excretion. Okay, so the amount filtered there per day, okay, is about 180 liters. Amount reabsorbed, 99%. Okay, the same there with the sodium. Okay, 630 grams. Okay, and you'll see there that 99.5 of it is reabsorbed. Okay, and the amount excreted there is pretty small. Interesting slides though. So what is reabsorbed and where? There's different sections, as we said. You've got the proximal convoluted tubule, you have the loop of Henle, you have the distal convoluted tubule, you have the three sections there. So about 99% of all sodium is reabsorbed, 99% of water, 100% of glucose. You never ever want to see glucose there in the urine, ever. About half urea, 0% creatinine. So the mechanism there of tubular reabsorption, it's all about the sodium. As we said, sodium gets pumped, everything else follows after. Okay, so we actively pump out the sodium, but through that process right there, the water and the negatively charged ions follow. Okay, so actively pump out sodium, passively these guys here will follow because we've got rid of those. Okay. And now tubular secretion. This is in the third section. Okay, so just getting into here, we filtered the blood. The blood continues on, right, because it's got a purpose, and the filtrate travels down. Okay, so in this section in the proximal convoluted tubule right here, most of the sodium there gets reabsorbed, the water gets reabsorbed, okay, and now we're into there the distal convoluted tubule right in here into the secretion part, okay. Moves very small amount of select substances from the peritubular capillaries into the tubules. Secreted substances, potassium ions, hydrogen ions, uric acid, ammonium ions. There's some drugs there that we want to get out. Okay. So in the distal convoluted tubule, okay, potassium and acidic ions may be passively secreted. Okay, and yeah, that's what we've got, and now we're moving on there to the collecting ducts there. Have a look there. That's slide 27. Have a look there at these movies. They give you some great ideas, better than just me talking and showing a screen. Okay, but make sure to watch all the movies there. They are awesome, and they give you there a great understanding. Okay. So urine making there, the nephron, the whole idea of filtering the blood. Most of 99% gets reabsorbed. Now you remember there that this is your cortex, this is your medulla, and you'll see there your loop of Henle dips down into the salty medulla, okay, where most of the water gets reabsorbed, okay, and then the distal convoluted tubule right here, this is for secretion and fine tuning, and then we are down in the collecting ducts. By this point in time, it's officially urine, okay. Love this slide here. There's your renal corpuscle, your glomerulus, okay. This one right here, they call the renal corpuscle, okay. This is your glomerular capillaries inside, your Bowman's capsule around the outside, okay. Love this here. There's your glomerulus, and there's your function. Renal tubules, there's your proximal convoluted tubule, and what is going on in it. Okay, great slide. You have the descending limb, okay, of the loop of Henle. You have the ascending limb of the loop of Henle. What is being absorbed? What is being reabsorbed? Okay, and then you have your distal convoluted tubule right here. What is going on in here? And then finally your collecting ducts. So as far as, please watch the movies and detail there what's going on in the nephron. This is a great slide as well, telling you what's going on the 4 different parts there of the nephron. Okay, 5 different actually. Renal corpuscle, okay, your PCT, your descending loop, your ascending loop there, the loop of Henle, distal convoluted tubule, and your collecting ducts. Great slide. Aldosterone and urine formation. Okay, it's impossible there to get away from hormones. We're gonna look at a little bit of hormones there in a little bit. Okay, works on the distal convoluted tubule and the upper collecting ducts there of the nephron unit. Salt retaining hormone. Remember, wherever salt goes, water will follow. So if we're thirsty, if we need to pump up that blood volume, you're going to withhold sodium there from your urine. And if you're going to withhold, so you're going to keep the sodium, well, then you're going to keep water. You're not going to urinate as much. And then we're also going to make you thirsty, so you're going to start dumping water, a glass or two water down your throat. You're going to be increasing the blood volume both ways. Okay, so that's what's going to go on. That's what's going on here. Effects increase. You retain the amount of sodium. You will retain water as well. Increase blood volume. Increase blood pressure. Okay. Great slide. Great slide here. Great movie that's going on here. The whole idea here. And when we get into hormones, which I guess we're kind of into now, you're going to see there that there's two ways there that the body talks to my big toe. Okay, my brain is up here, big toe is down here. My brain wants to talk to my big toe. It can do it through the nervous system. Okay, very fast, efficient, quick, short-lived. But then the other way there the brain can talk to my big toe is via the endocrine system, the hormonal system. And oh, these people in these chat groups, they just can't just send one text message. They have to send one sentence and then hit send and then write another sentence, hit send. Ugh. Anyway, sorry for the rant. Let's get back to the kidney, shall we? The how the brain talks to the my big toe can do it nervous or it can do it hormonally. And you're going to see there that it's quite strange, the endocrine system, where we produce a chemical that induces the production of another chemical that will induce the production of another chemical, which will then finally get to where we need it to go. So yeah, it's hormone to hormone to hormone to hormone. That's how this thing goes. We'll get there. But you'll see there that when we need to increase the blood volume in the BP, okay, you'll see there the liver produces what we call angiotensinogen, and you'll see there that the kidneys produce renin, because these juxtaglomerular cells there, right in the hilum, these ones here are measuring, okay, the blood pressure, and if they're not getting the BP there that they need, then the kidneys start producing renin. Okay, so renin and angiotensinogen there, they produce what's called angiotensin 1, okay, and through the use of the ACE, okay, angiotensin converting enzyme, okay, we're able there, that one there is produced in the lungs. You're able there to produce angiotensin 2, which is this one here, allows us to produce aldosterone, which then you'll see what it does there. It's all about vasoconstriction. Okay, so the arteries, remember they're made of smooth muscle, okay, and what they'll do is they'll vasoconstrict. So therefore what you're doing, and you think about it, vasoconstriction, you're making the arteries smaller, their diameter shorter. So what are you doing to your 5-liter tank? You're making it smaller. So if you, the whole idea of 5 liters of blood, if we can reduce the size of the tank, you've now increased the blood pressure as well. Great movie there. Have a look at that one. Series of events that go on in the renin-angiotensin-aldosterone system. That's this one right here. Okay. Most important stimuli for the release of aldosterone is renin. Okay. So the kidneys are watching. The kidneys are always monitoring. Okay. Renin is an enzyme that activates the what we call the RAS. Okay, renin-angiotensin-aldosterone system. Series of events. The renin there released from the kidneys because of low blood pressure. Angiotensinogen, which is an inactive form, is circulating there in the blood. So there's your angiotensinogen. It's in active form, but when it combines there with renin, okay, it now becomes angiotensin 1. Okay, the lungs release what we have a converting enzyme, which then changes angiotensin 1 to angiotensin 2. Aldosterone there released by the adrenal cortex, and that's these guys here that sit on top of the kidneys, okay, like a hat. And then the distal tubules, okay, the kidneys reabsorb sodium and water and excrete potassium. So that's what's going on. You'll see there that the RAS, the renin-angiotensin aldosterone system, targets this area right here. Okay, so if we need to, we can secrete things back into the blood right here, so we can secrete sodium, and therefore now we wherever sodium goes, water will follow, so we can plump up the blood volume as needed. Okay, and also about vasoconstriction. Just another shot of the same thing. Okay, if you didn't like the previous two, there's this one right here. Okay, there's your liver, angiotensinogen. There's the renin there from the kidneys. Okay, it produces angiotensin 1 through ACE converting enzyme, angiotensin converting enzyme produced in the lungs. We now get angiotensin 2, and the end results here: vasoconstriction. Okay, increased aldosterone secretion, which then targets there the distal convoluted tubule as well. You also get increased antidiuretic hormone. And you think about antidiuretic hormone, anti-diarrhea. We all know what diarrhea is, but anti-diarrhea, so you're keeping water in. Okay, increased thirst. We want to get that blood volume up. Okay. ADH, antidiuretic hormone, released by the posterior pituitary, okay, in response to low blood volume or very high concentration like syrupy blood, right? We need to get that blood watered, and we need more blood in the tank, because the more blood that's in my 5-liter tank, the higher the BP blood pressure we need. We do need a high blood pressure, not too high, but you need it there so the kidneys can do their job. Water moves out of the collecting ducts into the tissue spaces and then into the peritubular capillaries. Antidiuretic hormone decreases the excretion of water and causes the excretion of concentrated urine. ADH works primarily on the collecting ducts of the nephron unit by determining its permeability to water. So antidiuretic hormone works on the collecting ducts. So even there is fine tuning as this urine is on its way down, okay, the renal pyramids there, those pyramids, there is still fine tuning that can happen. Okay. Good. Parathyroid hormone and calcitonin. These guys here, okay, now we're talking about calcium regulation. Okay. Parathyroid hormone is secreted by the parathyroid glands. We'll talk more about these. It's just about foreshadowing. Okay, we'll introduce these there next week. Okay. The thyroid there sits above the heart there on the anterior portion of the chest. And the parathyroid, these are little glands on the back side of that. Okay. And this is involved in calcium reabsorption and regulation. Regulates the electrolytes calcium and phosphate. Primary stimulus, low blood calcium. So parathyroid gland releases parathyroid hormone when low blood calcium, okay, and starts robbing the bones of calcium. Now, when the blood when the blood calcium is too low, parathyroid hormone will go to the bones and start robbing the bones and dumping more calcium into the blood. Now, there's no turn-off switch. So the blood calcium is getting higher and higher and higher and higher, and then the thyroid gland will release calcitonin, which then all this high blood calcium, we can't just throw it out, so we put it back on the bones. So it's a back and forth, back and forth. High blood calcium, thyroid releases calcitonin. Low blood calcium, parathyroid releases PTH. Okay. Characteristics of urine. Average there about 1.5 liters in 24 hours, give or take. Okay. Oliguria, less than 400. Polyuria, when you're peeing too much. Average pH is slightly acidic, somewhere in the range of 5 to 8. Okay. Slightly heavier than water, not too much. Normal urine color there is amber or straw colored, but you can change the color of your urine. Okay, dehydration, it'll become a deep dark yellow orange, pale yellow if clear. Overhydration, if you just take a vitamin there, B12 multi-complex there, in a half an hour there, your urine will actually be kind of a bright neon yellow green highlighter color. Okay, so all depending, and you know, the whole idea there that you are what you eat, and that's why when you walk into a doctor's office and you say, "Doctor, I'm sick," they say pee in a cup, because they can tell a lot by what's going on. This just urine just came from the kidneys. If the kidneys are properly functioning, then you are probably properly functioning. All right. Yeah, about 95% water, usually contains urea, uric acid, creatinine, may contain trace amounts of amino acids, but never any sugar. Okay. Urinary retention there. The kidneys produce urine. The bladder won't empty. It happens. And where you guys are going, that will happen a lot. You may have to put in a catheter, okay, to allow people there to go to the bathroom. Renal suppression there, the kidneys don't produce urine, patient develops uremia, and now you're 12 hours a day, you're by a machine there in order to clean the blood via kidney dialysis. Devastating, devastating. Renal dialysis here, the whole idea, it's cleaning the blood when the kidneys won't. Okay, urine in the blood resulting there from, and so uremia there, urine in the blood. The kidneys aren't able to get the urine out, okay, due to kidney failure. Dialysis removes the waste from the blood, artificial kidney, peritoneal dialysis. Okay. Pathway of urine so far, we've looked at the nephron, the glomerular corpuscle. We've looked at the collecting ducts. We've looked at the collecting tubes. There you have the proximal convoluted tubule, the loop of Henle. Then you have the distal convoluted tubule, the collecting ducts. Renal papillae, these ones here are found at the bottom, okay, of those pyramids. Please make sure to watch the videos. There's one long video, I think it's like 10 minutes long. It goes into, with great detail, you know, the different anatomy and parts there of the nephron. I really recommend there that you have a look at it. Okay, take the 5-10 minutes, watch that video there. It's a really good one there. Renal papillae, there's always a question on the test. Minor major calyces, renal pelvis. And this is where we're going to be there for the remainder of the PowerPoint there. We're moving on down to the ureter, the bladder, the urethra, and to outside. Okay, just a reminder there of the system. Okay, now we've looked at urine formation. Now we're going to look down the ureter, the bladder, and the urethra. The medical word for urination is called micturition. It's called the micturition reflex. The bladder fills, stimulates stretch receptors. Now there's a type of epithelium, okay, I'll just write this in here, transitional epithelium. These are, you remember your, there's the pseudostratified columnar epithelium, we've got columnar cuboidal, we've got all those different kinds of epithelial cells. Well, there's another kind of epithelial cell called transitional, and these are for the bladder. And these epithelial cells, they are able to stretch, and it kind of makes sense, right? Because the bladder will fill up with urine, and eventually, you know, at some point in time, this thing is going to start to bulge and stretch. And these transitional epithelium there, they have a point of no return. So once they stretch past a certain point, they start sending a message there to the brain, hey, get this guy to find a washroom. Okay, so transitional epithelial. Good one, stretchy. Okay, stretch receptors. Here is a shot there of the ureter itself. Oh, lovely formatting. I don't know why there's... There we go. Good. So you'll see there, about 25 centimeters long, extends downward posteriorly there to the parietal peritoneum, parallel to the vertebral column, as we saw there, you'll see. Okay. Wall of the ureter there, we've got a mucus coat, muscular coat, and fibrous coat, as you can see right in there. There's really not much to it. It's all peristalsis moving that urine down. The bladder, hollow, distensible muscular organ located in the pelvic cavity, posterior to the symphysis pubis and inferior to the parietal peritoneum. Love that medical jargon, don't you? The internal floor of the bladder includes a triangular area called the trigone, which has an opening at each of the 3 angles. Okay, the urethra itself, tube that carries the urine there from the bladder to the outside. Okay, and here's just a shot there of the urethra. Okay, and you'll see there when you're talking the male and female, the female is much more prone to UTIs, urinary tract infections. It's just because the urethra is a very short distance there from the outside, and the potential there for infection is much greater. Okay. Just a shot there of your trigone. Okay. Yeah, everything looks great there. So we have, yeah, and that's it for the kidney. And I think that just for what I will do is I will keep the, I'm going to stop sharing, and I'm going to stop the video, but I'm going to keep the, I'm going to keep this open. So just let me